That's getting it started. The next button I push is going to start allowing people to come in to the site. We should see the numbers start jumping up on participants.
Okay.
Okay, that's done. And we're live on YouTube and we're ready to start. You ready to start the webinar?
Yeah.
Okay, there goes the button. And that's when the participants start coming in. We're at 8 now, 13. I'll turn my video off so I'm not distracting, and the show will all be yours. Well, there's 47, 56, 64. Looks like there's going to be a few of us.
Sounds like it.
There's 88, 91, 101, 118. Okay, we've got about 1 minute, and you're ready to go then. It's all yours. We're 169 so far.
Right, are you seeing my presentation now?
I am seeing your presentation. It looks great.
Yeah, good.
Okay, Don, you're on.
Oh, right. Well, hello, everybody out there. And I have no idea who's out there or where you all are, but good evening from wet, windy, cold Somerset in the west of England. And this presentation, the title I think is self-explanatory, but it came about with an interview I did on TX Factor. And I don't know how well TX Factor is known in the States. It's a TV program for amateurs, by amateurs, professionally produced. And they had interviewed me a few years ago at my old QTH, and then they were intrigued to find at my new QTH that I was still doing a lot of amateur radio, but under restricted conditions. Now, why might you be restricted antenna-wise? Well, maybe you don't have space. Maybe you don't have planning permissions or zoning approval, as you'd call it in the States. Maybe you don't have approval from your partner. Maybe you just want to be flexible with antennas rather than having a permanent setup. But whatever, the question is, what can be done? That's the challenge that you're all facing. And let me just say a little bit about myself. I've been a ham for over 50 years now, 53, I guess. I have all countries worked and over 3,000 on the DXCC challenge, and many contests and DX operations over the years, from 55 DXCC entities at the last count. It would have been more, but I couldn't travel last year, of course. And I'm looking forward to getting out and about. But in the meantime, I'm trying to do what I can from the home QTH. And on those expeditions, I've generally been part of the antenna team, and at T32C, which some of you will remember was the biggest expedition ever in terms of number of QSOs made, over 200,000, I was in charge of the antenna design and planning and installation. And I used to have a 60-foot tower at home with a step IR antenna. And that's how I did so well. But it's not an option for the present QTH. I agreed with my wife, I wouldn't try and put up towers here. We are what in the UK is called a grade 2 listed house. So there are restrictions on what we can do anyway. But drawing on my DXpedition experiences from 9M0, D68, 3B9, 3B7, etc., voodoo operations from Africa and elsewhere, I think portable. And the photograph on the left, incidentally, was when I was in ZC4 with a bunch of friends, and we put up antennas on the beach, and you can see that we were using verticals, and most of those would have been elevated ground planes. I think we had an inverted V dipole on 40, but most of those antennas were verticals of one sort or another, which of course work very well by the sea, but not necessarily inland. So we don't necessarily take that as the solution. Now, what I would say is that there's a huge choice of simple multiband antennas. out there, commercial ones I'm talking about. But are they the solution? It's a very easy solution. It's one that a lot of people will go for, but they're very often highly compromised. And this particular commercial antenna in the photograph here is one that I reviewed for Practical Wireless magazine. I edit Practical Wireless. It's a sort of CQ magazine of the UK, if you like. It's an independent magazine. And I reviewed this, and the length of it is about 1/4 of a wave on 20 meters. And it was supposed to be a multi-band commercial antenna. But frankly, comparing it with a simple elevated quarter wave on 20, it was chalk and cheese. This thing, I don't know, I think it was a multi-band dummy load, to be honest, being a little bit unkind, but something simple and cheap was far, far better in performance. So, and let me just move on. Why can't I move on? Aha. There we go. Let me just show you this slide, and some of you will have come across it, I'm sure. In July 2000 in QST, Tom Schiller, N6BT of Force 12 antennas, wrote an article called Everything Works. And his point was that you could load up a light bulb, as you can see the bottom left of the lower graph. But fun increases with the efficacy of your antennas. And he pointed out that a full-size dipole can work better and hence produce more fun than, for example, a trapped tribander. So the top graph shows fun versus the efficacy of your antenna, a dipole probably somewhere in the middle of it. Yes, world record potential if you've got a really big antenna system, but we don't all aspire to that. We're not all K3LR or W3LPL. But a dipole is not that far down on the big Yagis, and is certainly an awful lot better than some of the compromised multiband antennas. He pointed out then, as I say, that a dipole can work better than even a trapped tribander. And in fact, when you're contesting, maybe 90% of your QSOs will be loud. The last dB or so is unnecessary. And just comparing for a moment, remember that FT8, FT4 can provide more gain than a slightly better antenna. They can give you several dBs more gain, whereas adding one more element to a dipole gives you 3 dBs. To get another 3 dBs, you need another 2 elements. To get another 3 dBs, you need another 4 elements, and so on. And the nice thing, of course, is that contests take place in organized periods, unlike DXing, where you really need to have a permanent setup. So, you know, even if you are subject to zoning restrictions and so on, there is really no reason why you can't put up something for a weekend. So let's move on. Verticals I've mentioned, that they take up little real estate, but they do need radials. They don't always work well. But you can see here my current QTH, my new QTH. Let me just, if I get a pointer here. This is a little cottage that our daughter lives in, and there's the main house behind it. And the garden at least backs onto fields back here somewhere. And you can see I have a vertical here, and this was one I had about a year ago. And I think this was supporting an inverted L for 80 and later for 160. And then a smaller vertical, probably for 40 meters there, just attached to the garden chair. We're fortunate that where we live in Somerset, the ground is very peaty. Very conductive. So throwing a relatively small number of radials on the garden does the trick. I have to take them up in the summer, but it got me started. And that was the main thing. Now, horizontal antennas can be better. You don't need to worry about an earth system. They may, of course, require a central feeder, and that can be a problem. You've got two supports, and then you've got this feeder hanging down halfway. But why not consider an inverted V? I've had tremendous success over the years with inverted Vs. They're not that much down on a horizontal dipole, to be frank. Now, the supports can be trees, temporary masts, fiberglass poles. What I would say is you need to avoid metal masts for verticals, at least, unless they're to be used as the radiator itself. So let's have a look at where this takes us. Now, one of the questions is, how temporary is temporary? Is it a day, maybe a contest weekend, maybe something for a week where there's a de-expedition on, for example, or maybe a whole season insofar as you just need to clear the ground in the summer so that the family can take advantage. It depends on your operating requirements, but just this last month, I made over 5,000 QSOs under my G3XTT and my M3D contest calls. But my antennas will come down for the summer, except perhaps putting up a small Yagi for 6 meters. It depends entirely on what your operating priorities are, but it's not necessary to enter every contest, and it's not necessary to be multi-band. And what I would say is I tend to focus on a single band these days in contests, trying to be multi-band anyway from the average lot is a challenge, because there are some big contest stations. I know there are in the States, but even here in the UK, there are some pretty big contest stations nowadays. So it's easier to find a category that works for you. And generally, that will be a single band category. And for example, in WPXCW last year, I came #2 in Europe on 3.5 megs. And I did that. I actually put up 2 antennas. I put up a full-size quarter-wave vertical, and I put up a low dipole. And sure enough, the vertical was better on DX, and the dipole for a lot of the time was better around Europe. And I could do that because I wasn't trying to be on other bands. I was just on 80. Incidentally, the guy who came first in Europe in that one was a Czech guy who was borrowing one of the big multi contest stations in the Czech Republic, because they couldn't put on a multi because of COVID. So I mean, he had pretty big antennas, pretty big station. So I was very happy with my #2. Just the photograph on the left here, you can see here is just a vertical that I used for an elevated 20-meter antenna, just tied, as you can see, to the pole that supports the clothesline. Of course, we don't use the clothesline in the winter, so why not use it to support an antenna? At least it's being useful. And you can see in the background there a couple of my other verticals. And in fact, this photograph is kind of looking back from the house, and you can see the field behind us. So how do I solve this problem? And this isn't the answer for you necessarily, it's how I do it, but it hopefully will give you some ideas. I use spider poles. Those are the German fiberglass poles. I do use fishing poles for the shorter ones, but for the long ones, the one I'm now using is 22 meters long. You do need to avoid cheap imitations. We took a cheap one with us to T32 along with some of the real thing. And when we tried to haul it up from horizontal, it just caved in. I use a push-up military mast, ex-military mast. You can see that in the middle photo. And I use Takadi poles. These are 4-foot pole sections. They were sold at Friedrichshafen. I don't know whether they're sold in the States. They're ex Eastern European military tent poles, believe it or not, but somebody bought a whole lot and has been selling them to radio amateurs. And they're quite useful because they stack one on top of another, so they can't collapse in the way that a fiberglass pole collapses. So I'll just have a look at some of the antennas I built with each of these, and then I'll go on to some other possible configurations. But before I do that, let me just talk a little bit about the station. And that may seem an odd thing to do. You know, a station is a station. But, you know, what I would say is don't compromise with the station, because you are going to have to compromise to some extent with antennas. So, for example, 1.5 kilowatts to a dipole will well outperform 100 watts to a Yagi. And even in the UK, where our power limit is 400 watts, that's still 6 dBs better than 100. And to get 6 dBs out of an antenna is quite a challenge. I guess another 6 dBs, that is to say. I do focus primarily on, and you've got this message by now, I hope, on resonant antennas. They're much easier to work with, but sometimes you want to just QSY to another band. So, you know, I do have a KAT 500. You can see it there under the KPA 500. There's the K3 and a P3. So I've got the Elecraft K line, and I can get going on other bands. You can see the main rig is an IC 7610, and there's an expert linear sitting under the desk. So let me just look at the spider pole. It's ideal for vertical antennas, lightweight, flexible. These poles have dramatically changed things. I was in Southern Africa some years ago with Chris Berger's ZS6EZ. We did an expedition to Walvis Bay and Namibia, and we took a Battle Creek special antenna. Some of you will remember that, for 4080 160. That was a great big heavy thing, a big metal vertical and then heavy traps. These fiberglass poles have just changed the whole approach. They're available in lengths up to 26 meters. I've got ones that range from 10 meters to 22 meters. This particular 22 meter one that you can see is ideal as an 80 meter quarter wave, a full size quarter wave on 80 meters, and yet the real estate it takes up is zero. I have it attached, as you can see, to an 8-foot fence post set in concrete. And this is very simple. I can push the thing up in about 10 minutes. From being fully retracted, just tightening up the various clamps on the way so that the thing doesn't collapse on me. And I decided for the CQ Worldwide 160 contest in January that I would try and load it on 160 just so I could get on and do some contesting. And I'm not proud of the photo down here, but it just shows what you can do. I had this commercial coil, which I put in, and it took the resonance down from 3.5 megs down to 2 point something. So I needed a bit more inductance. And as you can see, I very carefully wound it on a professional former, or to put it another way, I put a few turns around the milk bottle and got it to resonate about 1815, 1820 kilohertz at the second attempt. And and you can see that some of the radials here, again, just disappearing around the garden, attached to just a metal block, and then into the coax here. So very, very unsophisticated. And for that contest, I also put up, I extended my 80 meter dipole, which I'll talk about shortly, on the ex-military mast. I extended that with a rather bent ends for 160. So I had a low dipole and I had this vertical, and I made 1,200 contacts. And I was very happy with that. I set a target of 1,000. And yeah, sure, the winning stations are up at 1500, 1600 QSOs, but I had fun, and that I think is the watchword. So here's my push-up military mast. In this case, it's a 45-foot mast, but they come in various shapes and sizes, of course. We had a few of these for our various expeditions with the 5-star group before it was disbanded. And I add a short fiberglass extension here, so you can see the guy ropes on the mast. You can't really see, but there's an 80-meter dipole on there, which, as I say, I'd also for the CQ Worldwide 160 contest extended for top band, rather bent round the garden, but then the current is up in the air there at 45 feet, most of the current, so fine. You can see how this works. That you push up the sections from this point here. So there's a little ladder that you can attach to it and stand on and push the sections up. You've probably come across these sort of things. And this is more than adequate for supporting a small Yagi for 4 and 6 meters in the summer season. I mentioned the Takadi poles that they slot together. They are tent poles. But I'm sure there are similar things elsewhere. And they're good to maybe 30 feet with guying. And the guy who sells them at Friedrichshafen and elsewhere has made up some guying rings that you can put between the sections. And, you know, they're ideal. Although, as you can see from the photograph at the left, that with this one, which was at about 20 feet or so, supporting a 20 or a 15-meter dipole, all I did was literally tie it into a tree at the bottom of the garden. And for multi-banding, well, guess what? I just add extensions with chock block connectors. You know, again, I can actually change bands between 15 and 20, between 20 and 40 or whatever in minutes if I want, just by adding extensions onto these antennas. And sometimes I need to do that. I operated recently in the FOC marathon event, which is a multi-band event, and I needed to be on multiple bands for that. I didn't try and put up 6 different poles around the garden. I just accepted that I could do 20 meters for a while, and then I would go swap the antenna and go on 15. It made instant QSYs impossible, but, you know, so what? Right. So what else have I tried? And, you know, having given you an idea of the sort of things that that I use typically, in the ARRL CW contest last year, I put up 2 quarter wave verticals for 40. So that's 2 10-meter poles. No, not difficult. Yes, they both need radials, of course. And one of the nice things from here in the ARRL contest is the States is in one direction. So you don't even need to be able to switch directions. And so for that, you know, I didn't try and do anything clever with the feed arrangement. I just had a couple of matching sections of the right number of degrees. And I looked it up in the book, and I needed obviously to work out the velocity factor of my coax, but with a modern antenna analyzer, that's a trivial thing to do. And just made a T arrangement to feed the 2 verticals, and that worked very well. I mentioned the low dipole I put up for the top band contest, but other antennas are perfectly doable. And, you know, I mentioned here loops and 4 squares and bobtail curtains and so on. And I'm going to go on and have a look at some of those. Some of them are maybe a little bit too ambitious, but, you know, I would argue that that we have the time normally, and we're not going off halfway around the world to set something up. So why not be prepared to put in a few hours at home to put up a decent contest station for the weekend? Phase verticals, you know, I've mentioned I used them in the ARRL contest, made about 500 Qs on 40 meters last year. But you know, if you want to be able to switch directions, you need a slightly more complex switching arrangement. Here's one. This is the so-called Christman feed system, taken out of one of the handbooks. There's other ways of making them work, but you know, basically you need a couple of quarter wave verticals, normally a quarter wave apart, but you can make them work at an 1/8 wavelength spacing if you're short of space. You can even put up 3-element arrays and so on. So, you know, phase verticals have a lot of potential. And although they may not give you the gain of a Yagi, getting a 40-meter Yagi at a height that works is a challenge anyway. And the nice thing about verticals is that you can switch direction instantly. Now, I want to just talk about loops. And here I show a full wavelength loop. And I've used these in the past from a previous QTH. They work very, very well, again on an insulated support. And you feed them a wavelength, a quarter wave from the top. As you can see, you have a quarter wave matching section of 75 ohm into your 50 ohm. And that will match the roughly match, well, near enough match the feed impedance at that point, which is probably going to be close to the 100 ohm mark. And away you go. And the advantage, of course, is that you're not having to put out a whole lot of radials. This particular diagram, and you can find these sort of things all over the web or in any of the regular handbooks. This particular diagram came from ON7YK's website, and he also has a calculator on his website, so you can put in the frequency you're interested in and it will give you all the dimensions. So you know, can't be bad, can't be bad. Now, a bit more ambitious maybe, but how about a 4-square? 4 quarter wave verticals, and you have a switch box in the center, and it dumps power into a dummy load. The switch box, sorry, I was going to say the switch box can be homemade. There's plenty of designs in the literature. But again, you can buy a ready-made system. I show the DX Engineering one here just as an example, but Comtech and other people make them. And all you need is the switch box, the dummy load, the control box with a control cable to the switch box, and 4 quarter wave lengths of 75 ohm coax. Now, when I say a quarter wave, that's an electrical quarter wave. So again, you need to know about the velocity factor of the cable. But as I said earlier, that's very easy to work out if you have an analyzer. Don't just take the manufacturer's published figures, because the velocity factor can vary. But what to say about a 4-square? Well, let me say something about it. Yes, it takes up quite a lot of real estate, quarter wave on either side, but you've got radials extending out of it. So potentially up to 3/4 of a wave in either direction. Of course, it doesn't have to be for 40. I mean, you can have equally use a 4-square for 20, 30, whatever. Yes, a permanent installation requires quite significant effort, but for a temporary installation, it doesn't have to be a major engineering effort. You can use elevated radials, as we did on our 5-star expeditions over the years. And when I say elevated, I'm talking maybe just over head height, so you don't get tangled up in them. Or you can use ground radials. And that was what I did at GU6UW in 1998, when I set a single op-all band record, which incidentally still stands 23 years later. Now that installation took a couple of hours. That was as it happened, 4 metal verticals, but they could just as easily have been fiberglass poles with wire. And I put, if I remember rightly, 16 quarter wave radials on each. And I'd pre-cut them and I was able to run them out fairly easily. And in fact, the biggest challenge with that particular antenna was that, as I said, I was doing a multi-band, an all-band effort. And the biggest challenge was pulling myself away from 40 meters after dawn, because I was working JA's long path well into daylight. So, I wouldn't rule out even what you might consider a more ambitious sort of antenna. Right, let's move on from there and just mention a couple of other possibilities. The half square antenna I show at the left here, again, is effectively a couple of verticals, but without the necessity of earth radials. And the current is up at the top because you feed it at the top corner, as you can see. Now, the challenge with that is if you're using fiberglass supports, they may not be strong enough to support the coax feed. If you're using a tree to support it, different situation. And I mentioned briefly the double half square, and you'll see why I mention it in a moment. But that is literally just adding another section to it, and that just narrows the beam width of the radiation pattern. Now, why did I mention that? Well, because it takes us nicely into the bobtail curtain. And this, again, is very similar, but the difference being that the center element is fed. And the first time I came across one of these was a GM station on the east coast of Scotland that I visited back in my university days. And he had one of these, and admittedly he lived on the coast, and he had one for 40 meters. And I was listening early afternoon to the Pacific coming in on 40, something I couldn't even imagine from home in the south of England at that time. So I was very, very impressed. And as I say here, any of these arrays can be supported by trees or insulated poles. It depends what you've got available, obviously. Now, I've avoided mention of the end-fed half wave, the W8JK, the G5RV, the ZS6BKW, etc., because they're all, to my mind, compromised multiband antennas, although probably more effective than many manufactured antennas. That's not to say you shouldn't put them up and have one of those up, by all means, to give you an all-band capability while you then focus your contest efforts on a single band with another antenna. But so just going back to single band antennas, they include loaded dipoles. For example, if you can't get up a full-size dipole, still better than a multi-band antenna, particularly if you can get the loading coils well out from the center. And I haven't mentioned the inverted L, but of course that's simply a quarter wave vertical where height is limited, and so the top is bent over, and it doesn't have to be bent horizontally. It can come down at an angle. Again, you may lose a dB or so, but you can still be pretty effective. And all of these are just variants on the vertical and the dipole. They're nothing clever. I've never ceased to be amazed at the number of antenna books and antenna articles that appear, because fundamentally the physics doesn't change, and most antennas are a dipole or a vertical with or without other elements, but there's nothing magic. Yes, there are loops, of course, the small loops, can be very effective for receiving. I'm not convinced about loops for transmitting, for example. And I am not talking about receiving antennas here, but there's no reason why you can't put them up. EWIs, the K9AY, etc., but they can be compromised if they're close to the transmitting antenna. If you've got the space, and you may well have, then certainly worth looking at separate receive antennas as well. So just some final thoughts. Time's getting on. Use good coax. Why waste power or introduce attenuation on receive? Again, it comes back to what I was saying about the station itself. Go for the best to make up for any possible limitations in your antenna system. And for your antenna system, invest in good quality wire, because it will take punishment when it's repeatedly being strung up and taken down. And at this point, I'd say that insulated wire is fine. Some of the purists say, no, you can't use insulated wire. You need bare copper wire, hard drawn, for antennas. No, that's rubbish. Yes, insulated wire has there's a slight velocity factor effect. And the length you need will be slightly less than the formula tell you. But as you, excuse me, but as you're only going to cut it once, and you're going to start with it being too long anyway and trim it until the SWR is where you want it, it really doesn't matter. And decent insulators are worthwhile, at least when it's wet. When it's dry, you can probably get away with just tying the ends of the antenna with some polypropylene rope. And balance are a luxury, and they may help to avoid EMC problems, but I tend not to use them with dipoles, to be perfectly honest. I did use a balun on that loaded 160 meter vertical, but that was because I was expecting the feed impedance to be somewhat less than 50 ohms. So I used a 2-to-1 balun at the bottom to match to the coax, and that seemed to do the trick. And I would say try and create a field of buried radials. You may want to take your antennas away during the summer, for example, or when you're not doing a contest. But if you bury radials, nobody's even going to know they're there. And then you can tap into them as and when you need to. Although you can always add more in the winter. And I found that effective. You can put as many radials down as you like, but the more the merrier. Although, again, there are lots of articles on the subject, and they tend to say that after about 16 radials, you get into a law of diminishing returns. Now, actually, if you think about that vertical, that 22-meter pole that I've got up, it's actually right in the bottom corner of the garden, so I can only put radials over about 100-degree range around it. I can't put them all the way around, but frankly, it doesn't seem to make a lot of difference to the radiation pattern. Although, again, the purists would say, well, you need the antenna right in the middle of the garden so you can put radials all around it. Now, just as a very, very last point, because all I've tried to do in this talk is give some ideas and some encouragement. The solutions for everybody is going to be different. But I was just going to say, in terms of resources, that there is a huge number of books out there, obviously, on antennas. There are modeling programs, and people have a lot of fun with those, Easy Neck and so on. And of course, you check on the web, Google is your friend, and you will find any number of antenna designs and theory and you name it, it's there. The quality varies, but there's some really good stuff. There absolutely is. So the takeout is be flexible, be prepared to be flexible, be prepared to configure for specific operating events. Be prepared to put in the effort. After all, if you're going to do a 24 or a 48-hour contest, why not spend a few hours or even a few days getting antennas set up for the occasion? I mean, here in the UK, our main multi station at Mike 6 Tango, or G0 KPW as it used to be, is set up field day style for every contest. And if we can set up multiple Yagis on trailer mounted towers, then to put up just a dipole or a vertical is surely not asking too much. But focus your operating on what works for your station, your antennas. And as I said, maybe that's single band contesting. Maybe it's chasing DX on needed bands. Just to give an example, when the VP8PJ expedition was on, was it early last year? I'm losing track. I needed it on 17 meters, nothing else, fortunately. So I just put up an elevated quarter wave vertical for 17. And work them second day of the operation. So you know, that was a nice one. But I would say keep a supply of ready cut dipoles, dipole extensions, feeders, and so on, so that you can run out things relatively easily and put them away relatively easily, and don't stint on the station equipment. And remember, as I said earlier, that contesting is unlike DXing. It takes place in designated periods for which you can plan, you can execute, and then you can just take the whole lot down afterwards, pack it all away until the next time. And that, I think, takes us to the end of the presentation.
Okay, Don, this is Ed again, your moderator, and we have 12 questions.
Wow.
So far. And if any of the other participants have questions, put them in the Q&A box and we'll try to go through them all. So the first one is from Bob, KC9RF. Have you tried 20 or 40 meter half square antenna?
No, I haven't, but yeah, the half square is another one. I'm sure it would work very well. Essentially, it's what I showed there, isn't it? With the you know, the top fed verticals. But no, I haven't tried it personally.
Okay, from Carl, great presentation. Have you tried any of the in-fed half wave antennas using a 49-to-1 matching transformer, such as those sold by myantennas.com? They can be used as inverted L's or inverted V's or verticals or flat tops. They are multi-band and seem to work well. Thanks.
Yeah, well, as you recall, and that question probably came in before I mentioned the end-fed half wave towards the end. I haven't used them. I know people who have, and they swear by them, but other people tell me that they are a compromise. I think they can work. But again, I'm not convinced that they work as well as a single band antenna, although, yes, they are a very good way of getting on multi-band. And of course, they're fed from the end. So you don't need any central supports or anything. But there's quite a lot of material on the web about them. And you do need a decent 49-to-1 balance, particularly if you want to run any sort of power.
Okay. From Paul, what's your opinions or experience with magnetic loop antennas?
Yeah, well, again, I mentioned loops towards the end, didn't I? That I think, you know, as receive antennas, they're pretty good. As transmit antennas, severely compromised and usually very, very narrow band. You know, at least one that works well will be high Q and therefore narrow band. I'm not convinced.
Okay. This is from Austin, AE5MU. He asked about Moxon antennas are great too. Or I guess the comments are great.
The Moxon antennas are very, very good, actually. Yes, I should perhaps have mentioned those. But I mean, it depends what one means, because the Moxons are usually, you know, Yagis, either tubular or made with wire, but you are talking something a little bit more ambitious that requires a decent support, a tower of some sort generally.
Okay. From Paul, what's your experience with antennas mounted in an attic?
I don't have any experience of antennas mounted in an attic. I wouldn't even consider it, to be honest. But I mean, yeah, I accept that some people are forced to have antennas in an attic. But you know, the problem will be that it will couple into all the wiring in the house. That you will have attenuation through the roof. Yeah, I mean, if you've got space outside, I would go for it, you know, rather than trying to put up an indoor antenna.
Okay, from Dave, what are your thoughts on ladder line used with a tuner?
Yeah, absolutely. Yeah, but particularly, you know, particularly if you do insist on having a multi-band antenna, then you're far better bringing ladder line back to the shack and the tuner. Rather than imagining that the feed impedance is 50 ohms at the center, which it won't be. But if it is 50 ohms, if it's a resonant antenna, which is what I've been advocating, then to be honest, coax is as good as anything.
Okay. From Mark, when building a half wave, quarter wave, ground plane vertical from wire, how do you determine trimming the driven element versus tuning the radials?
Well, normally the radials should be very slightly longer than the driven element, but I don't bother. I mean, I just go for pretty much the same length for each. But the way I usually do it is I cut the radial slightly on the long side. I then trim the driven element until I bring the thing into resonance. And then I usually will trim the radials very slightly just to try and get the SWR down. But frankly, once you get below about 2:1 SWR with any antenna across the range that you're talking about, then you're fine. You don't have to get to a 1:1 SWR. But in my case, my amplifier doesn't like anything more than 2:1. So, you know, I'm aiming normally for about a 1.5:1 SWR.
Okay. From Dick, how would you rate an inverted V versus inverted L?
Oh, well, it depends what you want to do. I've had a lot of success in some of our RSGB contests, our national contests, using inverted Vs at about 40 feet on that ex-military mast that I showed. An inverted L is no use whatsoever for those events because I want reasonably high angle of radiation around the UK. An inverted L is going to give you a much lower angle of radiation and therefore more suitable for DX working. And that takes me back to why I've used two antennas for some of the bigger contests, one to work the near-in stuff and one to work the more distant stuff. But as I say, you know, and in fact, this is a problem that some people have in those RSGB contests. They've got a very good DX antenna up and they just can't succeed in those local contests. So it's horses for courses.
Okay, that's from Dick, and he wanted to make sure you knew his call sign, not N9EEE.
Thank you.
David asked, what radial system, number, size, orientation did you use with the 80-160 vertical you highlighted in the talk? Any modification when you added the 160-meter coil? And I think you mentioned you had about 100-degree arc to put your radials in that location.
Yeah, I did mention that. That's right. And I have maybe 12 or 15 radials. I could do a lot better. These are not resonant radials. These are on the ground radials, and they don't have to be resonant. In fact, I would argue that if radials are on the ground, the length, there's no such thing as a resonant length because they're going to couple into the ground anyway. So you just put down as much wire as you can, and I don't change the radial system between 80 and 160. People say to me, how many radios should you put down and how much wire? And I say, well, do you have wire hanging around in the shack? because a lot of my wire has come from club junk sales, and as long as it's in the shack, it's not making the signal any better. But if I put it down as radials, then potentially it may. So why not?
Okay. From Jack, thank you for your presentation. Which modeling software would you recommend? Is there one more suited for wire antennas versus Yagi's, or are the software packages pretty much all encompassing?
And I think, MMANA or EasyNEC are pretty good for wire antennas. I believe Yagi Stress is the one to use for Yagis, but I don't have experience of all of them. I just read about them, I'm afraid.
Okay, several folks said, thanks, great presentation. I've got Arthur says you skipped in half-wave antennas, which is simply a half-wave dipole on a specific frequency. Any thoughts on this if elevated either vertically or sloped?
Sorry, I didn't quite. Are you talking about using a vertical half wave?
I was talking about an in-fed half wave, and thoughts on elevated either vertically or sloped.
Oh, okay, an end-fed half wave, yeah, and that's fine if you can find a way of successfully feeding an end-fed half wave. Then why not? And one of the problems of a vertical half wave is how do you feed it? And you can end feed it. You can't feed it halfway up generally, although on our expeditions we use what's called a vertical dipole array, where you've got a driven element and a reflector, and then you can take the feeder out from halfway up the dipole and out behind the reflector and then down. I wouldn't recommend a VDA necessarily for a home station situation. But yeah, an end-fed half wave can work if you can find a successful way of feeding it. But of course, the end impedance will be very, very high.
Okay, I have two questions here. One I can answer, I believe. This PowerPoint and presentation is being recorded right now on YouTube Live, so it'll be available in the future. And the other question is for you, your personal favorite wire antenna books. And I think you showed us 3, but he's asking for your personal favorite.
Oh dear. Yes, I have a whole bookcase full of antenna books, I must admit. I'm not sure which are my favorites. To be honest, with the antennas I've described, you don't need, big books, although I do enjoy reading about antennas. I guess we all do. So that one, Simple Wire Antennas, I think you saw, but that, I think, if I'm right, and I'd have to go back and check, is an RSGB publication. The ARRL antenna book, of course, has got everything in, but is quite expensive. But there are a lot of books around on simple wire antennas of one sort or another.
Okay, from Tom, how about inside antennas? I cannot put up an antenna outside. I'm thinking of a slinky toy dipole.
Yeah, what I would encourage is, going back to that slide by N6BT, anything works. You can feed your bed if it's got a metal frame. You can feed your light bulb. You can certainly feed a slinky, but it's going to be a compromise, and you won't have as much fun as being able to temporarily at least put something outside.
Okay. Have you used a vertical dipole configuration? Anonymous attendee, but he thanked it as Paul.
Yeah, I think I answered the vertical dipole thing. The problem is feeding it. And if you have a reflector behind, you can take the feeder out behind the reflector and down. But otherwise, it's a bit of a challenge. So what I tend to do instead is use an elevated quarter wave vertical and 2 radials, and then you can feed it, feed the quarter wave element directly underneath.
Okay.
And it's very similar to a vertical dipole, of course, but the radials come out at maybe 45 degrees. And the only reason you have 2 is just to balance up the pattern.
Okay, Gerald has a question. What's your opinion of off-center fed dipoles, the Wyndham feed antennas?
Yeah, OCFDs and Wyndhams can work remarkably well, but again, they're multi-band antennas, so I would argue that they're a little bit of a compromise. But I have used Wyndhams with great effect. So again, any of these antennas are worth looking at. But what I've tried to encourage in this presentation is looking at nice single-band antennas, 50 ohm feed. Just keep things simple.
Okay. Don asked, how about using stainless cable versus copper wire?
Oh, I always use copper wire. I've no experience of stainless. I guess it would work, but I would be. I believe I believe the resistance is quite a bit higher.
Okay, we get down to 1 minute left. I'm going to look through these other questions real quickly. Expedition use from David. What 2 or 3 antennas would you favor for HFDX, considering temporary location?
Oh, on expeditions, we use elevated quarter waves. We use, as I've said a couple of times, the vertical dipole arrays. We use those very effectively from Tango X-ray 6 Charlie and the Austral Islands. We could only beam one way anyway, and we were right on the beach. So yeah, I mean, vertical arrays. On some of our expeditions, we had the luxury of having Yagis and also being able to try out verticals against them, and the verticals generally were as good as the Yagi.
Okay, unfortunately, we've run out of time. Thank